Okay, we're recording.
So are we ready? Yes?
Yep, we're good.
Okay.
Go ahead.
Well, welcome to the October 20th, 2020. How amazing is that? Session of Tangerine SDR and Hamside Personal Space Weather Station development. My name is Dave, KV0S, and this week Dan and I had a meeting with Bill, and so we've made some progress talking about some software changes. And Scotty and Tom and I have actually been in discussions about getting a programmer working. So maybe we'll talk a little bit about that too. So those are the two SDR related things that I've been involved in. So let's go down the list. And next on the list is Nathaniel, W2NAF. Go ahead.
Thank you very much, Dave. Just keeping things going here in Scranton and working on teaching and things like that. We met with Casey, Kirby Patel, and Jonathan Rizzo and Bill Lyles last week. I guess Jonathan will tell you a little bit more about that, but that was about the VLF board, and Scotty was there too. So that's pretty much what we're up to. W2NF, back to net.
Well, fine business. And next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to you and good evening to the net. Well, as Dave mentioned, I had a telco with Dave and Dan early in the week to talk about the idea they have that to take the software they've developed that works with the Tangerine simulator and maybe make a modification, rather enhancement to it. Yes. That would allow it to run using Raspberry Pi as the data source. And if it's done right, in other words, HPSDR protocol compliant, that means a number of other software-defined radios would possibly be able to be used with my software.
There was a confused look by Scotty, but you meant Red Pataya and or HPSDR protocol.
Yeah, right,
general.
Right. Yeah, must have misstated something there. But anyway, aside from that, I've been going through the software and adding in some logging features that you can control what level of logging you have, starting with, you can get just errors. You get no logging, and we're talking about going into the Linux system log, the syslog. So you can get just errors, errors and warnings, or also notices, or all info, and the highest level is debug, in which case you get everything. And I'm thinking that this will be helpful to support this once we roll it out to a bunch of people. Undoubtedly, there will be bugs, and I'll tell them, oh, turn on the debugging logging, and then try and reproduce your error, and then send me your log off of var log, and then hopefully we can figure out what happened and come up with fixes for it. We'll also have to talk about how we're going to distribute this thing. There's several ways to do that, though, but I know that we do want to try and have something that which we can update it, and then people will get the updates semi-automatically or something like that. So anyway, that's been my week. So back to you, Dave.
Very good. Next on the list, we have Dave Witten, KD0EAG. Dave, welcome back.
Hello. I have not accomplished a thing this week due to some medical things that have gone on, but that was expected. Thought I'd try to get on here tonight, slowly getting back up to steam, but it's taking a little longer than I thought. Anyway, back to you, Dave.
Fine business, Dave. Welcome. Glad you're back. Next on the list, Dan, W4XWE. Go ahead, Dan.
Thank you, Dave, and good evening, everyone. Went through Bill's code, kind of quickly, a couple of days ago, have gone through his build instructions for it and parsed all of the dependencies and have that pretty much under control. I'm kind of approaching this as something that I can use to write a script to install it. And I actually found a very, very nice little script tool that allows you to use menus to pick out which scripts you're running. And you can have as many scripts as you want within the context of the program and choose whatever you want to start. And I can see some real applications for what we're doing in managing like this, managing it like this. Also started back to work last week for the first time in about 7 months. So I've been kind of busy with that. And as I was telling Dave earlier, I wasn't planning on working today, but I got a call early in the morning. One of the guys was sick, so I ended up taking over for him. So ended up working on a day which I was not anticipating working. So, one other thing is I actually was, before everybody got on here, I was accessing Zoom via my Raspberry Pi 4. It actually got it working. It worked pretty well until people started coming to the Zoom site, and then it just slowly died. So it was a nice idea, but it didn't work out very well. Anyway, back to you, Dave.
Fine business. And let's see, next on the list, we have David McGaw in one HAC. Go ahead, David.
Good evening, everyone. I sent off a couple of magnetometer boards back to Dave after
Appreciate that.
debugging them, checking them out. So you should have those in a couple of days. Something to do in your recovery.
Yeah, I'm looking forward to that.
And I'll put a question out there. If one has a red Battaya, can one start running this software and trying it out?
Well, as far as I know, we'll need to make this one little change, but
And it's not such a little change. It's pretty. Yeah, but
Right now-
talking about this bit of code and a little change.
yeah,
Uh-huh.
but
Simply a matter of programming, right?
That's all.
Yeah.
That's software.
simply
That's
software.
That's all it is.
That's
how
what Scotty
big of a
always
little
tells
change
us.
is it?
What was the question, Nathaniel?
When we get to the open session, you'll have to tell us how
Yeah,
big
we'll-
of a little change it is.
We'll
Yeah.
talk about this later, but I just throw that out. Seems
I have a red Battaya sitting right here.
Yep, me too. So we can
So
touch
let's
it.
see.
keep checking things out.
Next on the list, we have Dev, KC3 PVE. Dev, are you there? Mic muted. Maybe he's stepped away. Let's go on. Next is Gary and Chris. Gary, go ahead.
Yeah, good evening, everyone. Just glad we have our full complement of Daves and Davids back. But other than that, just reading the mail. Back to that.
Yeah, you kind of have to be a Dave or a David to be part of the group, right? Okay, next on the list, we have James. Go ahead, James.
Mind if we call you Dave just to keep things clear?
Yeah, you can call me Dave. I'm just here listening in, trying to learn and enjoy the time on Mondays. So back to the net.
Very good. Next on the list is Jonathan Rizzo. KC3 EEY. Go ahead, Jonathan.
Hi, everybody. As Nathaniel said, I met with KC last week, and we were discussing the VLF module, and what her needs were for her Eclipse Mob project. Apparently her Eclipse Mob receiver is based on, I believe she said a PIC32, and it has an A to D converter, which can do filtering on the fly. And she's only interested in the narrow swaths of bandwidth like WWVB. So we she explained her the way that her system would work, and it would connect to a Raspberry Pi, and she would get small quantities of data based on her filtering, whereas my system will capture the whole spectrum. And Scotty and I, we left off with characterizing the frequency response of the CS5364, and we were discussing the evaluation board, and somehow getting it interfaced to a computer where I could use VLFRX tools and terminate the inputs and get some frequency characterization on each of the channels. We were discussing different ways to do it. The dev board outputs, it primarily outputs SPDIF that from what the data sheet of the evaluation board said, it uses, or Cirrus Logic recommends these audio analysis instruments, which obviously I don't have, but a computer sound card would work. But I was wondering if there was a cheaper alternative, because this dev board is about $400, and it's just a fancy dev board with an FPGA, the A to D converter, and some SPDIF outputs. And the USB interface to the PC is only control; it's not audio. So we left the discussion at that. Back to the net.
Well, fine business. And I see Dev is back with us, so we'll call on Dev. Go ahead.
Good evening, everyone. So we had a good week last week, and we're starting for a new week, and I'm continuing to work toward detecting chops with the receiver that we think we have rightly assembled, but getting it going very smooth. We're still a few steps away from the goal. Thank you.
Okay, very good. And let's see, next on the list is Michael, AAK. Go ahead, Michael.
Greetings to everyone on the conference, and back to you, Dave.
Fine business. And let's see, next we have Scotty, WA2 DFI. Go ahead, Scotty.
Okay, Dave, thanks. And let's see, this week did quite a few things. Like Jonathan and Nathaniel said, we got together and talked a little bit about the VLF module and its other applications, or other applications of the clock module, I guess. Also worked with John, and I've been exchanging some emails with John and Tom about the clock module, about configurations, and John Ackerman is currently working on the schematic, and he's progressing along. I'd say you can comment, Tom, but I think he says he's about 3/4 done with it on the preliminary schematic. Let's see what else. Oh, I went ahead and put the order in for the updated magnetometers, the RevDs, which correct the problems. So we should have those in another 2 weeks or so. And I already have 5 working ones and 25 modules. So when we get the remaining 45 baseboards, then we'll have enough to do 25 sets of magnetometers. So we'll be swimming in magnetometers. So we'll have to get together with you, Nathaniel, and figure out whether you want me to send them all to you or whether you want me to send them out from here or how we want to do that. And back on the VLF module, I think if we need to talk to you, Nathaniel, to see if we have a budget maybe to buy that board. But I wanted to make sure that we could actually have a way to hook it up and use it and get useful info before we plunk down $400 and find out that, well, we need a PC with SPDIF inputs and we don't have that. But you know, you can buy an SPDIF sound card with PCI sound card for probably not a lot of money.
Mm-hmm.
And I'd just like to be able to take a look at the noise floor and the intermodulation of those particular chips that we're going to use for the VLF module. I think it would be worthwhile to have some kind of data on the thing. And I've been I keep meaning to get together with the Cypress FAE, and I haven't had a chance to do it yet. But I want to touch base with a local person here and see if it's possible I could get a loaner, which would be actually great because we could use it for a month or two and then send it back and not pay anything. So it'd be much better. So I think that's about it. Back to you, Dave.
Well, fine business. And we're to Tom, the last on the list again. Someday I'll have to start at the bottom and go up.
This way I can be last and least at the same time. No actual work, just a bunch of emails conversing with folks back in the day.
Okay, thank you, Tom. So I think we're ready for general discussion. I haven't seen anybody jump in there that I didn't catch.
I'll jump in for a moment on the evaluation board that you're thinking about. You might contact Cirrus directly and mention that this is a student project. They may just be willing to.
Well, interestingly enough, there's local sales offices, but Cirrus happens to have a factory office in Arizona.
Correct.
It's in Mesa. It's right next door here. So it would be contacting the factory really, rather than a satellite FAE office or sales office, something like that. So that I could certainly ask and tell them what it's going to be used for.
Yeah, I know most of these companies have a educational outreach program, and I would go there first.
Okay, I have a question for Tom. I talked to, well, I got an email back from you on the 10 megahertz reference input that circuit that Hermes used to use.
Yes.
And I was just curious because they seem to go to an awful lot of trouble. I just managed to close my window here and I don't know where it went. So
I can still hear you.
So I'm just looking at nothing here. It seems to me that they went to an awful lot of trouble to build a circuit that was some kind of like common emitter type of amplifier, differential amplifier is what they used, and the transformer coupled it and all of that. And I'm just wondering what your opinion is on why they did all that, and if just that input Schmidt trigger gate would be sufficient, because I would read the data sheet, and if we run that part on 3 volts, the input will tolerate up to 7 volts on the input. So that takes care of the level translation, at least if you get a minimum of, say, about 2 volts coming in. But I don't know why they went to all this trouble of isolation. Do you have any ideas?
Well, the input circuit is supposed to be a differential amplifier with one side, centered at a particular bias voltage. But there's a bunch of problems with the way it was implemented. The emitter resistor was too big. The output stage of the diff amp is a transistor pulling to one rail and a resistor pulling to the other rail. And there was enough capacitance on the Hermes circuit that the RC time constant on the output of the diff amp prevented it from actually reaching the logic levels that it needed to. Why they did it that way, I don't know. But quite frankly, I just think a CMOS gate is less expensive and a lot less trouble. The clock buffer I replaced it with, the plug-on board, used one of those Schmidt trigger parts to get around the diff amp.
Okay, what about the transformer coupling? You have any?
I don't remember that part. It's been a long time since I've looked at the circuit.
Well, here, I'll give it to you if I can share my screen. It's in the upper left corner here. I don't know, is that big enough for you to see? Okay.
Okay, yeah, I can see that. Yeah, well, the transformer is nice in that if there are, you can isolate the ground of Hermes from the return side of the cable feeding the 10 meg reference, so you can avoid noise induced by a ground loop. That noise, I think, is extremely small compared to the size of the problems that differential amplifier imposes. Yeah. And so a lot of work was put into that, but because of the diff amps problems, that transformer is essentially kind of wasted in the circuit.
Well, so if we use the gate, would that transformer be useful?
I disagree that the transformer is wasted. That's supposed to break RF ground loop.
Yeah, and if it had a good input circuit, it would. The problem is that emitter follower there couldn't reach logic level outputs that would clock the succeeding stages.
But if we substituted a 7414, the gate that you were talking about, the Schmidt trigger type digital gate, then we get a good logic output if we could get enough input drive to get past the thresholds.
Right. If you have a logic gate that can actually logically toggle the output, then the transformer is beneficial because you can break the ground loop. So the difficulty they had was just with that particular circuit design.
Yeah.
Okay. But if we were to use a transformer like that and capacitively couple it into the Schmidt trigger, do you think we'd get enough drive to drive that gate?
I think so. Yeah, the CMOS device is high input impedance.
Okay.
It's possible we could use a step-up transformer. You, for one thing, you want to have that 50 ohm terminated, which it is not in this circuit.
Actually, it is. If you look
I see. There's an enable. Yeah.
Down here.
Yeah.
That's really not, that should be called terminator. The enable's over here.
Right, but you can put that on the input side and then have the secondary of the transformer step up. Or you could terminate it with like a 250 ohm.
Well, you could use like a 4-to-1 transformer.
Right.
And use a 200 ohm resistor.
Yeah. That's what we often do.
Yeah.
I've run circuits many times for that.
Okay, and then you can capacitively couple and you have no...
Now, where did this differential amplifier come from? Is
you know, this amplifier circuit never really worked right, as Tom said. And so I did some Google searching after we had built a few hundred Hermes boards, and which of course is very useful after the fact. But I found this circuit actually online. It's almost identical circuit with a couple component changes. And we ended up changing, I believe, the emitter or the collector resistor here. Yeah. We actually could fudge that and we could get it so it would work pretty well if you had enough drive coming in.
I'm wondering about the transistors themselves. So I don't recognize the number, but they might be slow.
Yeah, 1132s. This is intended to be 10 megahertz only, not any faster. But
right, but you still want it fast to get it to switch cleanly at logic level.
Yeah, the problem that the transistors, as I recall, were pretty fast at driving that output line up in level from the output, the collector of Q4. It could drive it positive, but it was that 270 ohm collector resistor that was way too large to discharge the capacitance of the load it was driving.
Right. Well, we can do some research. I know, we time nuts use circuits to square up 10 megahertz all the time.
Yeah.
And, if John doesn't have a good idea, we have plenty of other resources.
Yeah, a simple Schmidt trigger, ACT 14 or HC 14, HCT 14 is pretty good. It's not to the level of certain time nuts, jitter performance, but for the vast majority of applications, it's plenty good enough.
Yeah, I've actually used just a high-speed comparator to square up signals. Yeah, that is an old transistor.
Yeah.
What's its switching time?
It doesn't have very much gain either. Turn on time 50 nanoseconds.
That's pretty slow. Yeah, that's why it's not working. 50 nanoseconds is half a period.
Yeah.
The problem, but in my testing of it, the transistor was quite a bit faster than that.
Yeah.
And I suspect that that's the spec for a really old process, and any modern devices are made with a much newer process. That's
right, but that's what that transistor is built to.
The Schmidt trigger is on the load on the order of like 5 nanoseconds.
Yeah, exactly.
So it's very much faster.
Yeah, the Schmidt trigger also has the advantage that it's got active pull up and active pull down FETs on the output stage, and so it can drive some capacitance with clean edges.
Yep, that should work.
Okay, so we'll consider using. I've used that particular part before. It just seemed like they went to an awful lot of trouble to not use an integrated circuit gate. I mean, that part costs about 12 cents.
Well,
so
that circuit
really no reason to not use it.
That circuit was designed to drive TTL. That's a very old circuit.
Well, yeah, we're running LVTTL, LVCMOS.
Yes,
so
I know. I'm just pointing out that it's not even a full 5-volt swing. It's a 3.5 volt swing.
Yeah. So, okay. Very good. That answers my question. And because we're talking about clock modules, and it looks like the way it's going to be is there's going to be really, I think we're only going to need 2 clock modules, and it may even devolve down to 1 particular board layout, because on the clock module we're going to have footprints for both the dual channel and the single channel GPS. So we'll be able to install either one on the same board layout. So that creates 2, a low cost version and a high performance version at the same time. And then if we, depending on how much we want to spend on the extremely low cost one, if we just retain the synthesizer and the oscillator, we can end up with something that is really low phase noise and high performance without any GPS at all. And so for the applications that don't need GPS timestamping, then that becomes the low cost option. And all you do is just depopulate both GPSs, and probably some straps we'll have to put on the board to configure it that way, or 0 ohm resistors. It'll be factory built. So from the user's point of view, there will be 3 different clock modules. They just will all be built on the same PC board. So it would help us out. And we haven't really determined whether that's going to be feasible or not, because the 4th option is the really low cost one, which is basically a Hermes copy. It's taking, because the clock oscillator from Hermes now, the $50–$60 one, is now down to about 12 bucks in quantity. So we can put that and just a buffer on the board. The only thing you lose when you do that is you don't get any synthesizers. So you get all 4 frequency outputs are the same, 122.88. So that creates a problem for Jonathan's low frequency module, because he needs a synthesized output. So he'll have to use the mid-grade clock module in order to use the low frequency module, unless and we're talking about perhaps putting a crystal on his board and figuring out a way to enable it or the external oscillator, so you could actually even run it with the low cost clock module and an onboard crystal. So it just depends on how we do the time stamping, and I think I can get him time stamping more accurate than he needs without having to use a external input oscillator. So but we're still discussing that, right, Jonathan?
Yeah, I would definitely be interested to if if you could get the time stamping very accurate, then I would love to see how that would work and if it is feasible. Um, right now, I didn't have any plans on going that route, but um, if you could make it work, I definitely want to learn more about that.
Well, John Ackerman is thinking that with the low-cost GPS board, we ought to be able to get to within about 10 nanoseconds. And I'm not sure what 10 nanoseconds of what. I mean, probably not UTC, but he's 10 nanosecond jitter, I think, is what he's talking about on the clock coming from the clock module. With the high performance GPS, he thinks we can do better than 4 nanoseconds of jitter. And at 122.88 megahertz, if I use that as my reference clock, which is the fastest clock that I have on the board, that's about 8.3 nanoseconds. So your timestamp's going to be interpolated between 1 PPS ticks and to the nearest 8.3 nanoseconds. So you add the jitter of the 122.88 plus the uncertainty of my clock. And so what are you going to get? 20 nanoseconds maybe of uncertainty? That's pretty good considering your samples are at 5 microseconds. So it's going to be highly accurate, I think, maybe more than you need.
Yeah, that sounds really good. That might work well. It might be a good alternative. Because Paul guarantees with the software and his GPS time stamping 50 nanoseconds within UT for
Yeah.
each sample.
Because if you imagine that I have a 122 megahertz counter clock running a counter, and the counter gets reset every edge of the pulse per second, then I basically take it to 1 second and I divide it up into 122.88 million divisions, if you will. And so then when the sample arrives on the serial interface at time X, I look at the counter and then I add the time of the PPS and I add the offset that the counter gives me, and then I add the latency of the transfer of the data from the A to Ds to me, plus I add the latency of the actual conversion. Both should be relatively fixed, I think. Then I think you're going to get pretty consistent time stamping to within 20 nanoseconds, maybe.
Yeah, that's a good idea. Yeah, we could definitely give that a try.
And then if we actually take one of your extra inputs and feed the 1 PPS into that, which I'm planning to give you a 1 PPS on the leaf interface. So you could feed that in, that we could actually measure the latency between the analog input and when I actually get the sample. See how consistent it is, how long it is, determine what it is to, because it's certainly, if as you change sample rates, that's the latency is going to change. So it'll be probably useful, I think, at least for our testing, to be able to measure it.
Yeah. Because I was even thinking about that, and just like you were saying last week, we could have a jumper, and we could jumper the 1 pulse per second signal to the fourth input without any issue at all.
Yeah, since it's an analog input, I mean, you could put a transmission gate on there, or I don't know what they use these days, but something that, because it's all you're measuring is the edge. So really, depending on what the coupling looks like, you could just, even a open drain or open collector device that's fast to pull it down.
That's true.
To get that edge. see the edge. And
Well,
then
Paul,
you could control it from the FPGA.
well, Paul uses he uses three methods. One of the methods that he has kind of perfected is he finds the centroid of the pulse by sending it through. So he sends a pulse per second signal through an RC network, and the resulting output, he has an algorithm that will look for the pulse's centroid, and that's how he knows that the 1 pulse per second has ticked.
So how do you mean he actually creates a ramp and looks for the center?
Yeah. Yeah, it's in, if you look in his documentation, it's in the timing section.
Oh, okay. In that webpage that you sent me the link to?
Yeah, abilene.org.
Okay.
I'll put it in the chat here.
Okay. Very good. So Dave,
Yes.
0S, did what I said in the email make sense? Was it clear enough, or was it totally
Yes. And I think the solution that I favor is if we can modify the Verilog code. I don't know how different the Max 10 is from either a Cyclone 3, Cyclone 4. And
well, just general Verilog code isn't any different, but the
it's the
IP is different because it has
the
two
memory. The memory's a different.
Yeah, the
yeah.
flash is different. Well, in fact, the Cyclones don't have any flash memory.
Yeah.
So there's no IP or no way to use any of that, obviously.
Well, what they did is they took some of the available memory in the Cyclone, I guess, is what they did.
Yeah, there's RAM.
Yeah.
Definitely there's RAM, and you can make ROM out of it.
Yeah.
So you could do that, and depending on what size Cyclone 5 you use, it can have kind of a lot. So
yeah. I was wondering if this is an aside, but would the same strategy work for the IQ2 to make the programmer work on it?
The IQ2 has QSPI memory, so the code would be different because we'd have to instantiate a QSPI IP block. Yeah. And then it wouldn't be that much different though, because the interface is probably just going to be an Avalon bus, which is the same. So
yeah, you need a chunk of memory, and you need Verilog that talks to it.
Right.
And that's basically, and then this little program runs, and you talk to it over an Ethernet port.
Right.
And that's all. Everything else is pretty much set up. Well, we have to change the packet links and things like that, but.
Well, you need an Ethernet MAC, and then you need you're going to need a NEOS to control the MAC, because if you want to get the speeds that we want out of it, you got to have a DMA engine. So that means you need a processor to set up the DMA engine. And that's relatively straightforward.
You'd asked me about that with your IQ2 at one time, if we could do it. And I hadn't thought about it, but working on this, I thought about that.
Well, we use a tri-speed MAC, which we actually go in and hack up a little bit, because it turns out that to be able to do 10, 100, 1000, you have to have a 3-way clock multiplexer. Okay. And that is the act of using the 3-way clock multiplexer limits you in your performance at a gig. So, and we say, well, nobody's going to use it at 10 meg. So we just throw that out. We make it a 2-speed MAC, 10, 100 or 100, 1000.
Yes.
And then we use a DMA engine to move data. And so we can get over 900 megabits per second over the Ethernet, because it just goes right into memory. So, I mean, with the NEOS processor, that there's no way that's going to keep up if you put it in line with the code, with the data.
Yep. So I think it's a doable solution, but I need somebody who has more Verilog background than I do.
Well, like I said, you're talking to the Ethernet part, right?
Yes.
So all you're doing is you're talking our protocol,
Yes.
except that, well, I mean, I guess we can start with protocol 1, but
Yes.
I'd prefer to not use that because it doesn't have error checking, right? Or retry.
Yes. The protocol 2 went to a lot of pains to add error checking
Yeah. So I
on
mean,
the packets.
yeah. So, and I think we should just out of the gate, we should use that unless there's
Yes.
not.
I was going to ask you about that, why you were using protocol 1, but I know it's implemented in several places and
Well, at the
it makes
time,
it easier.
at the time we did the IQ2, protocol 2 was just coming out.
Yes.
Really, there was nobody there's no software that used it.
Right.
So even if we implemented protocol 2 in the FPGA, there was nobody to talk to it.
But the programmer that I wrote, I have a version for protocol 1 and a version for protocol 2.
Oh, okay. So you've already done protocol 2.
Yes.
Oh, okay.
On
Well,
my
good.
side, but I haven't done the Verilog side.
Yeah. Okay. Well, that's like probably, I guess, my first task.
And I
after
have those available both in C and Go, and I have them so either language,
So
and I have it
compile
in
them-
command line or working as a web server.
So can we run it as a web server on the
Yes.
Odroid?
Yes.
Well, the Odroid will have enough oomph. I guess it will. It's not very
Well, it's a really, I mean, it doesn't, the web server part's not a big deal.
That'll be
And
cool.
the nice thing about Go is it compiles on ARMS or X90 86 machines. It doesn't.
Well,
In
so
fact, they're even working on a RISC-V version, but it isn't ready yet.
okay. I mean, when you say it's a web server, then what's it written in for that? Are you writing?
Go.
You're writing the Go version for that? Okay.
Yeah, I have a Go web server. I don't know if that'd collide with Bill's, but if we gave it a port number, it should be fine.
Yeah. So, Bill, what are you using for a web server on the Droid?
Flask.
Flask?
Yes.
So it's a Python based.
Yeah, it's Python based, right?
Yeah, well, you could do exactly the same thing you're doing with Go in Flask somewhere, you know, because it supports the same kind of stuff.
So basically, I just have to get packets in and out for the programmer. That's all I really need to have. And I use the web server to collect the configuration data. That's all it is.
Okay.
But I have a command line version of it too, which Bill would love. He loves the command line version, so he could just stick it right in there. Although I don't know if you want the thing that we had trouble with before was people would try programming the firmware and didn't fully understand what they were doing and muck it up. It didn't break it. Well, it broke it for them, but then they thought it was dead. and then they have a fine, but you have to go back and
I did
start
that.
again.
I bricked mine. I didn't understand how it worked because one's called the programmer and one's called the loader. And it's like, well, what the hell, what is which? I don't.
Well, it was two different purposes built into one program. That was, John did that.
It was confusing anyway. We're going to make it so simple.
And that's the reason I took it apart and made two programs.
Well, we're going to we should only need one, right? I mean, we don't.
One was to, if you erased all your flash, there was one that put everything back to the factory settings. And the other one was just to update the software.
Well, if you erased all your flash, then you better be using the Byte Blaster because there's no bootloader or anything left.
Right.
Right. Well, we're not going to allow that.
So, but the bootloader was always there. You wouldn't erase that. But what they would do, some people would go and use Quartus and write over everything. And
they would write over the bootloader also?
Well,
or just their
Quartus,
code?
you know, they didn't know where to put it. So the way it worked on Hermes is the bootloader started at 0 and the programming code started at 1,000,000. And if you put your programming code at 0, it worked, but you could never change it.
Right, because you erased the bootloader.
Yeah.
Well, we're not going to have that problem because the Verilog code is not going to allow you to write. I mean, if you want to write Verilog, you can go in and wreck it.
Right.
We can't stop that, but we can prevent you from doing something dumb that we enable you to do. We won't
Yes.
enable that.
Yes.
So, in fact, I've been working with our little development board here, our Intel one that
Yes.
you and Dan and I have. And I've got it so that I can actually instruct it to reload the other image.
Oh,
And,
very good.
and the code that I have installed will actually, I put a UART in there and I can type a letter, a number, and select whether I want to reprogram the flash or
Okay.
switch back to the other code. So now I can go in there and I haven't got the loader part to work yet. That's not really I wanted to prove that I could load each image and switch back and forth between the two.
Right.
That's what we're going to need to do. So I put the bootloader in CFM1, configuration flash memory 1, and I put the program in CFM0, and I made the LEDs go a different pattern so I could tell which one I was on.
Right.
And I can go in and I can switch back and forth now between the two. So
very good.
And by the way, the code that Altera gives you is junk.
Yes.
it doesn't work right.
I got swamped by all the stuff that they provided, and I was thinking, where is all this going? This is doing stuff that is nothing like what I wanted to do.
They do writes and they don't wait for the ready bit to come back.
Right. Yes.
And it's like, you can't do that, otherwise it doesn't work.
Yes.
I know. I tried it. Their way, it doesn't work. So if you go in and fix their code, then you can get it to work. So I mean, I've got the UART spewing out messages and telling me what to do and being able to switch back and forth. So
okay, very good.
Pretty good, I think. So all we're missing right now is the Ethernet part. So we can because I'm doing this over a serial port.
Okay.
So, but putting in an Ethernet packets is not really that much different.
No.
So, just putting a layer of protocol 2 over the top of it.
Right.
So when I get that going, you're ready to test right away with that because you have code already? Or are you going to have to modify something to?
I'll have to modify it, I think, but I'm hoping not too much.
Okay. And then what kind of files do you load? You load RBFs or?
Now, the way Hermes and Metis work, they did RBFs. I couldn't find any information in the Max 10 on RBFs. It only talked about SOFs and POFs.
There's there's one called a raw device form, RDN, I believe it is.
Okay.
There's too many acronyms. I can't keep them all straight, but it sounds a whole
well,
lot
RBF is raw binary.
Right. So it sounds like an RBF to me because it is basically just hex data.
And Quartus still spits out RBFs, right?
No, you have to do these RDN files. It's different.
Okay.
But I can't figure out what the difference between a raw binary format and this RDN is because this is just raw binary, it looks to me. So I don't know.
There's got to be something different that's a gotcha.
Anyway, there's now a POF file creator in Quartus.
I did see that.
Right, and you can use it to you combine soft files because the difference between soft and POF files is the POF file has addresses in it.
Okay.
And the soft file it just programs RAM, so it just programs a RAM image. So it combines soft files, and what it does is it arranges them and adds the addressing in and makes a single big POF file.
Okay.
And you can also add in hex file for your NEOS code.
Well,
and you put it all in one big giant POF file.
So what I would do with an RBN is I just chop it into little pieces, send it over to the flash in Ethernet packets, and then it has to be just written in the right place.
Yeah.
Concatenate it all back together on the other side.
Well, and the IP was really stupid. It only does 32-bit writes.
Yeah.
4 bytes at a time. There's no bursts. There's no sectors. There's no nothing. It's 4 bytes at a time, which is really.
Yes, I did see that.
So are you doing on 256 byte sectors, or what block are you?
256 is the kind of normal. And then John had one part when you put the bootloader, let's see, when you're talking to the bootloader, it did it in 64 bit.
64 bits or 60
bytes, sorry.
Bytes. Because if we were to do that, we would have to buffer them up, right?
Yeah.
Which I think, well, 64 bytes is 64 blocks of 4 bytes would be 256. That would be a sector.
Yeah.
I think we have enough memory to do that because you just stuff it into RAM.
Yeah.
And you could do the checksum on it before you did any, even because you could do sector erases, I think.
Right.
The way we do it right now is we just erase the whole thing,
right.
all of CFM0,
right.
which is all right, but
and we had in protocol 1 we had no sanity check on any of the pieces.
No checksum or anything?
No. We just put it all in there, and if the whole thing failed, you start over and do it again.
That's horrible.
In protocol 2, we check each packet, and we get a affirmation that it was received correctly.
And if it isn't, you do retries?
You do a retry.
Okay. That's much.
Which is a little more normal.
And so you do like 100 or 256 bytes, and then there's a checksum with it, or CRT or something?
Yes.
Okay. So that'll make the software a little bit more convoluted, but not much. It's pretty easy to buffer that up.
Yeah.
It's just that, and the thing that's good is on our end,
I can make those things as big as your buffer can or whatever you're taking can handle it.
512 megabytes.
Well, I don't know. I could try.
That's bigger than the flash is, but no. The thing about this is, we have tons of QSPI and tons of RAM.
Right.
So the project I'm working on now has no QSPI and no external RAM. Okay. All the code and all the memory has to reside inside the FPGA, and you're limited to 64K bytes of flash and 162K or some weird number.
And are you updating this real, or is it you're writing it once with Quartus?
We start out writing it with Quartus once, and then the updates come in, and we only update CFM0 ever.
Okay.
We don't. The program doesn't even have a facility to update the bootloader. If you want to update that, you got to use it. So that would be a factory only option, or for people who have. I mean, I don't really envision updating the bootloader. Do you?
No.
So I mean, once we get one that works, unless we make a stupid mistake, which is always possible.
Well, I sent you a link to at least the protocol 1 bootloader.
Hello.
Hello? Oh, Dave? He's talking to his cat, I think. He muted himself. Scotty, all the Verilog code is in the Tapper SVN, or not SVN, Tapper GitHub.
Okay, but you talked to Phil's code, right?
All the old code is in there.
Even the
Verilog.
For protocol 2?
For both protocol 2 and protocol 1. So we have a template to start from. Now it's for a Cyclone 4 chip, and there should be one in there for Cyclone 3, which I don't know if they vary much.
Because the logic elements differ, but the code is the code. I mean, the compiler takes care of it, except that if you use IP blocks, then the IP blocks will be different. Right. And that's what will get you, that will bite you in the rear. is then, like I told you, when I went from 18.1 to 20.1, the RAM IP would not compile anymore.
Okay.
And I went back to Altera and they said, oh, well, you have to use Linux.
Oh.
It's broken in the Windows version. You have to use Linux.
Now this old code on the Verilog side was written by Joe Martin.
Oh, it was. It wasn't written by Phil?
No. Now
Okay.
Phil may have modified it, but Joe Martin's name is on it.
So did Joe put a Neos processor in or not?
No.
Okay, so he stayed with Phil's state machine type of design.
Yes.
Okay.
And he was usually the one, when we had to make corrections, he would make the next version.
Okay, because I'm not going to do that. I'm going to put a Neos processor in there because it's going to be much easier to update.
That makes sense. I would think it would be much easier.
Besides, then it'll be only software, and you know how hard could that be?
Yes, that's right. You got Bill going there.
I'm gonna want help with this, okay? Because this is not my area of expertise.
Well, if you can get the Verilog, I want to be able to read what you're doing, but I don't think I could write it from scratch myself.
No, but here's the cool thing: is it's set up so that you compile the hardware portion that goes in the FPGA, which includes the Neos processor, all the peripherals, all of the IP, and that comes out as a descriptor file called an SOPC info file. And then the Eclipse tools, which are where all the software is generated, reads that file in, creates a board support package by loading all the drivers that the hardware you specified needs, and then you write your code, and we can set it up so that you can write your code, compile it, add the hex file in at the bottom of the standard file, run it, find an error, go back, fix the error, recompile it, and you can go around in this loop really fast without ever seeing any Verilog code or any of the innards of the FPGA, but you've got your own little private world of Neos 2 code runs. So it's pretty good. They did a good job of that because it helps the software and hardware communities not freak out over, you know, me having to learn software and you having to learn Verilog.
Right.
You know, even though I know everybody here is going to want to look at it.
Yes.
But, you know, if you don't want to look at my software.
Well, what I've found is lots of people look at Verilog code, but not very many people dip their fingers in.
And it's like me and software. I mean, I can read a program and figure out what it does, but give me a blank sheet and say, make it do that. Not so easy.
Yeah. Well, we all have our talents.
Yeah. So I took a look at what Jonathan sent, that link. That third, if you click on that third diagram there, that's exactly where they stole it from. Okay, because that's the exact circuit that they use.
Oh, okay.
And that's the one that I found when I did a Google search too. So, but I can't really, it doesn't work like it says that it does.
Yeah.
You do not get 5 volts peak to peak out of the thing. It just, either if it's the transistors are too slow or what it is, I don't know. So, and they're using 3906s, which are like, bleh, you know.
Yeah.
That's like,
well, if you, as I point out, this source runs it off 10 volts, not 5 volts.
Ah, there's the difference.
It at 5 volts, it doesn't swing 5 volts.
Yeah, right.
It'll only swing about 2.5.
So half the voltage, basically.
Half the voltage,
if that.
And then I don't know. They're not. Do they talk about frequency in here? How fast they can run this thing?
These are generally, you know, where you putting 10 megahertz through there or something.
I would think 10 would be a little pushing it a little bit. But anyway.
But it does mention, you know, what we had talked about: transformer, direct couple. Just above the transistor, the diff amp version talks about using a resonant circuit, which, given that we're only talking 10 megahertz, could work also.
It might work, yeah.
That gives you a step up.
Wonder if you could use a transformer in place of the inductor and resonate the secondary of the transformer.
That doesn't quite work because the transformer is supposed to have a very low mutual inductance.
Oh, okay.
It'll look It'll look resistive.
Yeah, one problem with that circuit is it really doesn't handle capacitive loads at the output very well.
So before we get back into this too
Yeah.
far, and I want to watch everybody's time at least. Dan and Bill and I had a conversation. We wanted to sneak in here for a little bit. My question is not that long. I don't know, Dan, do you have other questions?
I have one question.
And I have one question.
Well, go ahead.
Okay.
I'm
They
kind of
might
on the-
both be long or short. We don't know. You want to go
Mine-
first, Dan?
Okay, mine's pretty short, I think, because it's just almost a yes or no. Are you using a 32-bit or 64-bit operating system, Bill?
It's 64.
So it's the beta, the 20.4 or 04 beta? Is
I
that what it
believe
is?
so. I believe so. Although I think I better check that now that you say that it's a beta, because I know I was running 64 on the Odroid, but I need to check that and give you a definitive answer
Okay.
about this computer.
I think the kernel version for that's 5.4.13 or something like that.
Release
Yes, it is.
20.04 LTS Focal Fossil 64-bit kernel Linux 5.4.0 1021 Raspberry AAR. Yeah. So
Okay.
it's 64.
Okay. Perfect.
Now, right now, I was trying to upgrade my N2, and it complained that the N2 didn't have all the stuff. And I'm not sure, because there was an automatic upgrade offered in the N2 software.
I said no to that.
Yeah.
Did you say
And
yes?
when I tried it, and it said you don't have all the prerequisites. Have you tried it, Dan?
I have not tried it, but I've never seen the message come up automatically either.
Oh, okay.
And I
So
know
you're
that
talking about the N2, the Odroid N2, or the N2?
The
Of what?
N2 running, yeah, the O2 N2 Odroid running
Right?
Ubuntu.
Yeah.
You're running like 1802 or whatever the
Right.
standard first release was.
Yes. And I got an offer. I don't know if Dave is still here. Or did he go? Yeah, it looks like
He left.
he left.
Well, just FYI, the Odroid that I did my development on is running release 18.04.5 LTS Bionic Beaver 64-bit kernel Linux. That's what I'm running on my Odroid N2.
Okay.
which I
That's what
have
I'm
several of them.
running as well.
Yeah. Same here.
And I was wondering if anybody had upgraded. I had
saw
Oh, you're up to
problems.
version 20?
Yeah, I tried upgrading to 20 and it wouldn't let me complete it. So when it rolled
Yeah.
back.
I saw that
Yeah.
automatic offer and I turned it down, but I can go back and. But you're saying it won't work?
It's was complaining about the PPA files not being right. And Dan would know about this, so I'm not sure if it actually runs on the ARM or not.
well, I know that the version that's on the website is 18.04. That's
Yeah.
the latest and greatest version that Odroid or hard kernel is offering on their website.
Yeah. And I did see a beta there, but I wasn't, since the reason I keep the Odroid running is to be compatible with all of you. I'm not, I want to stay in sync.
So Dan, you haven't upgraded to 20, right?
No, I have not.
Okay. So it's
And-
only on the Raspberry Pi we're using 20, right?
Exactly.
Okay.
And you're interested in this, Dave, is because you need it for the software for developing the firmware, the bootloader?
No, no. I'm using 20 on all my other machines. Either Ubuntu or Mint. They're both using the base 2004. And so if I just try to work on, it's a lot easier to work on a full featured Linux machine than a smaller machine. So I'd like to get it working first there, and then try to go back to either the Pi or the Odroid.
Yeah, I was surprised when the N2 Plus came out. I'm surprised that they did not upgrade the OS to 20.4.
I did find a beta in their list, their directories, but I'm not sure if it's. I wasn't sure how fully baked it was.
Yeah, the Odroid, rather for the Raspberry Pi, I'm using I think it's an Ubuntu server.
Yeah.
But
so yes, I found that website. So did we get your question answered, Dan?
Yes.
Okay. My question is, everything that you gave me worked like a gem till I got to compiling, and you had include files, H files that were in quotes. And my background is that if it's quotes, you need an actual relative address or an absolute address for quoted H files. And one was the DE something.h. I can't remember.
Signals, probably signals.
Yeah, signals. And I have not spent time digging through all the directories to find that.
So, let me see. It should be.
I was just wondering if you had an alias that you always look in a certain set of directories.
Well, I think it's in the. I'm thinking it's in the make file. It includes it as there's a capital I. It's been 6 or 8 months since I built this. So,
yeah, I use just a plain make.
Yeah, well, there is I mean, this wasn't set up really for consumption by anybody else just yet, and I'm proud of you that you got that far so far with that.
And basically, I don't want to cause a bunch of trouble for you. I just want to know where to look to find these.
Well, yeah. Let me see here. Trying to think if am I actually, what am I using this for? There is, if you go into projects, Tangerine SDR Pi, then there is a directory called includes. And the only thing
includes, okay.
The only thing that's in there is signals.h. I thought I was going to have more of these, but it turns out that was the only one I had.
Okay. All I got to do is in your code, put the directory relative and it'll work.
Yeah.
I'm hoping to get it all compiled, and they'll be compiled on a regular Ubuntu.
Yeah, that's a good direction.
But I got all that far on Sunday.
Very good, very good, excellent. Yeah, for anybody else who's interested on this, what we've been figuring out so far is that all right, I use at the beginning when this thing starts up, I use the UDP discovery protocol that was written by John Melton for finding things on the wire. And if you have both my Tangerine data engine simulator as well as a Red Pitaya, it'll find them both. And right now, well, it knows the difference between because the Tangerine puts a different device type in, I think it's in byte 10. And as of right now, for phase 1, I'm doing it very simple-minded. It just takes the first Tangerine it finds, and that's what it hooks to. In the future, we'll give it a chance to display all the different things it's found and let the user pick what they want. But
I'm curious if it'll find the Hermes, which reports a packet that's identical, just with a different number.
it should, yeah. And in fact, if you look at the stuff that's come spitting out from the on the console, it should list the devices and what type they are, and what type it thinks they are. Because there are some devices that masquerade as others, but it uses Melton's original code. So if it could do it, then it should.
Yeah,
it should.
It works fine in Lin HPSDRs. So
yeah. So the idea is that we'll add some code that if it recognizes that the user has selected the red Pitaya or something HPSDR compliant, it will use that protocol for talking to that device. And then the real meat of the processing is done by some separate processes that get spawned off for doing the FT8 whisper and ring buffer data collection coming from the binary streams. And those will copy it and change it so it recognizes the kind of data that the red Pitaya puts out, rather than VITA. I'm wanting to make the data engine output VITA 49 or VITA T format. So we'll also have a flavor of this is able to read the old HPSDR output standard.
Right.
And once you can do that and then adapt it, all the other stuff should be pretty easy to get working. So we shall see.
So it's kind of what's happened is we've spent a lot of time on hardware, and you have a number of software people sitting around waiting for something to work on.
This is going to change pretty fast.
Yeah, there'll be oh, you guys, why don't you have it done yet? Right?
Yeah, because after all, the hardware, when it's done, the project is done, right?
That's right.
Well, that's why
I've been through this with Open HPSDR. You know, you sit around for a while, and then the software comes along, and you know, not everybody has all their time to spend on just this.
Well, we'll tease you a little bit with some magnetometers.
Yeah. Sounds good.
Well,
now I realize
that's why I started working on this and developed a simulator and stuff a year ago.
Yes.
So that we could have a software product that's at the same level of completion as the data engine as soon as you have prototypes.
Yes.
So,
well, and you put a few things in there that got me interested. That's why I wanted to pick up on it.
Just the one thing is it you know, the way we're doing it, you'll only be able to copy at most 2 channels of stuff. So you won't be able to run 8 channels of whisper and 8 channels of on the red Pitaya. You should be able to run all kinds of stuff simultaneously on the data engine, because the protocol will support that, but the old HPSDR format won't support that. So
I just realized there's a question. Red Pitaya, there are 2 versions of it. Is this compatible with the older?
Now you can get, they've made the Verilog changes so that the 2 have all the same software suites.
Mm-hmm.
And if you go to the website, it now has the 2 pieces of code. So you either have to download the 14-bit or the 16-bit.
Right.
And this is mostly thanks to the German hams that use it.
Right.
So
is Charlie 25 guys.
Is the 14-bit one the old one?
Yes.
And the 16-bit one's the new one. And
the new one, and the new one has a GPS on.
Yeah, and the new one's the 122.88 megahertz clock, whereas the old one has 125 megahertz clock. which causes.
Okay.
And I actually have
disparity.
one of each, so I've tested it.
Yeah, I've got one of the old ones, but I
Yeah,
realized, oh, different clock rate. Mm.
Yeah.
I have an old one too. It doesn't happen to use the Christec oscillator, does it?
I don't remember
I
what
don't
it
know.
has.
I need to go look because I could swap that out and make it a 122.8.
Yeah.
Well, that would really.
But they
confuse it.
they added a lot of filtering on the input and output.
Because I remember rumors
sockets.
that when you're talking Ethernet, it interfered with the front end.
Yeah.
And so they fixed that on the new one.
I don't know.
I hope so. Well, I hope we don't have that
I
problem.
mean, it talks Ethernet on both.
It's Gigi, right, on both?
Yes.
Hmm.
Well, I don't want to belabor it, but we're
We're way
past
over.
our time. Unless there's something else somebody needs to ask.
So when do you want to get together, Nathaniel? You want to do when do you have time? I know you're busier and I'll get out.
Oh my gosh, it's been crazy. Let's see. I don't. Maybe Friday afternoon.
Okay, because we got a couple of weeks still, but I want to be ready. So
When is a couple weeks?
couple of weeks is, you want a real date?
Early November.
End of the month.
Like Halloween.
Halloween.
Wow.
Yes.
Yeah.
I actually have.
I'm hoping to turn off all the lights and hide inside on Halloween.
I have 5 boards, so I have 2 sets right now, but I'm reluctant to send them out because I haven't determined how I'm going to program the ROMs yet.
Okay.
So I want to do that first, and then when I get the other ones, we'll be ready to go.
Okay. Yes.
Anyway,
Not-
we can just exchange emails. We don't really have to sit
That
down and
sounds
hash it
good.
out. Start out that way anyway.
Yeah, I think that sounds like a good plan.
Because I mean, there's people who could obviously use these right now.
Yes.
And there's others that probably won't be able to get to it right away because they're busy with other things. So
Right. That sounds good. Yeah. Yeah, so why don't we exchange emails, and then certainly the people that we know need them right away, we can get them to them.
Yep. Sounds good.
Yeah, I think that sounds really great. It sounds like we're making really good progress on all of this.
We are. I actually got back on the data engine today, so
That's awesome.
It's good. I want to get it over with and in hardware, so then I can say, "I'm done. You saw
That'll
the
be amazing.
I'm done."
But you're
Oh, we'll
still not-
find
you're
some
not really
jobs
gonna be
for
done.
you, Scotty.
Yeah, I know. Well,
Yeah.
that's the problem is hardware done is not hardware done.
All the firmware still.
Yeah, that all has to be done.
Well,
So,
it's just software, right? It's like everything else.
but
You
know
did
what?
tell us you were an expert on Verilog, so
I'm tired of doing hardware. I want to do Verilog now, so it'll be fun.
good. You can
That
teach
sounds
us a little
great.
bit about it.
Sure. What little I know enough to be dangerous, and you get some things working.
Well, I followed your article and I did pretty well till you got to the last page, and then it kind of faded.
And then I went off the deep end and lost.
Well, I
it.
couldn't keep up with where you were going. So
Yeah, it's really hard to
I'm
tell.
talking about his QEX article.
It's hard to tell what the proper rate is, whether you're exceeding the capacity or I don't know. So, and you after you've done it for 20 years,
Yeah.
then you can't really understand somebody's mental set coming from no background at all. It'd be like you guys trying to explain how to write C code to me.
Yeah.
It's like there's just terms that I don't even know that that software guys just know and they understand it and I don't. So then it becomes difficult because you can't even explain it.
Mm-hmm.
Like I asked my buddy, well, what's the difference between object oriented? I have that.
There you go.
Hey, I've actually took a course on that and I went through that whole book, but it was so many years ago. Hey, and I have Have you seen the book that's called Bad C Programs?
No.
No, it's a cool book, and it has these examples in them of things not to do. So,
Do you have code examples that look like that?
Yeah, I got that book around here somewhere. I bought it because it sounded like a great title, and especially for somebody beginning, you don't want to go down the wrong path.
Mm-hmm.
Like Yogi Bear says, when you come to a fork in the road, you should take it.
Yeah.
So
I have to tell my story now.
okay.
I lived just a mile from the fork in the road.
Oh,
Did you take it or not?
Well, yeah. So the story is my mom lives in Bloomfield, New Jersey, and Yogi Berra lived in Montclair, which is the next town over. And his house is at the top of this hill, and there is a fork in the road, and you could go either left or you could go right, and you'd still get to his house. So he's giving directions to his friend. He literally said, when you get to the fork in the road, take it, meaning it didn't matter which way you went.
That's what that meant. So all these years we've been taking this out of context.
That's right.
And laughing at the poor guy.
So you can go there. You can go there, and there is a little rock and a monument. It has Yogi Bear's quote on it, so you can actually go visit the fork in the road.
oh, great. Hey, Scotty, did you know Yogi Bear is from St. Louis?
He is?
He grew up on the hill in St. Louis.
Oh, I didn't know that. Okay, cool.
And he played ball with a bunch of other famous St. Louisans.
Oh, yeah. His quotes are great.
So,
like the restaurant that no one goes to anymore because it's too crowded.
Yeah.
Mm-hmm.
And our coach used to tell everybody, the football coach, I want half you over there and half you over here, and the rest of you come with me. They actually put that in the yearbook too. I probably got in trouble for it.
All right, people.
Okay.
Going QRT, enjoyed it. 73.
Yes.
We'll be in touch.
Yep.
73, everybody.
So where Nathaniel go? Can you leave this up for a few?
Yeah, sure.
So I can bug Dan?
Yes.